Hello, I'm Dr. Chris Fiekowitz from the Computer Science Department at HWS. I'm going to talk a little bit about our curriculum. I'll start with the question of what is computer science, and then I'll talk about details of the courses that we offer, and I'll wrap up with a short discussion about careers in computer science. This is a quote from the course catalog that mentions the technical knowledge necessary for working with computers. But what is that technical knowledge? Usually the first thing people think of with computer science is programming, or what we call coding. And this program that I'm showing here is certainly an important part in computer science, but there's a lot more to it. If you read the full quote, it says, beneath the technical knowledge, computer science is very much the study of how to think critically. So what does that mean? Well, that means whether you're working as a team or as an individual, the goal is to analyze the problem that you're dealing with and use the techniques and the theories behind computer science to solve that problem. So that's ultimately the goal. Even though the technical knowledge is very important at the top, there's a much more fundamental goal in mind. So let me talk about the details of the courses we offer. The launch pad that takes you through the course of the entire curriculum is 124, Intro to Programming. So this course teaches you how to design programs and write computer code using a real-world programming language. And even though no prior programming experience is necessary, it covers many essential concepts and skills that are absolutely essential for you to succeed through the rest of the curriculum. Now, once you have 124 in your toolbox, there are a couple of courses that take you and expand your horizons in different directions. One is 220, Intro to Computer Architecture. So you've probably heard of binary numbers, those ones and zeros like the ones shown here. But the question is, in 220, how do those ones and zeros, and more importantly, the software we write, actually work on computer circuits? Because if we can't build computers to run our software, then the software won't work. So computer architecture takes you down that path and helps you understand the connection and how the hardware actually puts your programs into action. Another course that you can take that goes in a completely different direction is 229, Foundations of Computation, which does not focus on programming itself or the computer architecture, but instead actually asks the question, what can computers actually do? What is computation in the first place? This diagram here is known as a finite automaton, and it's just one of many ways that computer scientists use to analyze how we can solve problems using software. Another very important course that builds off of 124 is 225, Intermediate Programming. So in this course, you go to another level, focusing on working with the data and designing algorithms to work with that data. It's a foundational course that's required for all the other courses that are available. And this diagram here is what's known as a tree. It's a sophisticated way of organizing data in software so that we can use algorithms to efficiently process that data. There are two other courses that are required for the BS and BA degrees that also build off of 225. One is 327, Data Structures and Algorithms. A data structure is just a way of storing data in a computer, and an algorithm is a way of using software to process or work with that data. This diagram I'm showing here is known as Dijkstra's algorithm, which is a sophisticated way of finding the shortest path between 2 points in a map. 329, Software Development, is a really fun course because it uses a team design approach. Just like modern software development companies that work on large projects, you work in a group to solve a much larger problem that you might than you might normally take on individually. And while you're working as a group to solve that big problem, you are learning modern software development techniques. We offer a lot of electives here at HWS. This is just a list of some of the ones we're currently offering, including databases, computer graphics, operating systems, compilers, computer networks, artificial intelligence, data mining, and computational neuroscience. And this list changes from semester to semester. Also, we support independent studies where you can design your own course. So if there's a particular topic that we are not offering in the electives, then you can always reach out to a faculty member that you think might be interested in supporting you on learning that material and design a course just for that. So lastly, let me talk a little bit about careers that intersect with computer science. The most obvious one that you might think of is being a software developer. So that just means writing code. And all kinds of companies have their own software developers, not just companies that make software and sell the software, but companies that use software often write their own. And for larger companies, they'll hire software developers to actually work inside that company to design and maintain their own software. But most software developers end up specializing in particular areas through experience. And this is just a very short list of some different types to give you an idea. Artificial intelligence, mobile application development, full stack web development just means designing the very complex websites and the software underneath those websites that make them work. As a completely different idea, user experience is a growing area of interest in being able to design software that focuses on how users interact with the computer programs and making that efficient. A different area that's sometimes not considered computer science, but really is closely related to it, is information technology. So information technology positions usually involve working with software very closely, even though you're not doing the actual coding or programming itself. So project managers are essential at companies that have large software projects like Google, Microsoft, and Apple, and even mid-sized companies that have large software projects require these managers to organize the software development group. And managing these groups benefits immensely by knowing how to code yourself and also understanding exactly how software works. Cybersecurity is a different area that people often focus on. And even if you're not writing the security software itself, understanding how it works inside is essential to making sure that you know how to apply cybersecurity techniques and protect data and software. Systems architects are people that work with combining software and hardware together for networks and other types of systems. And again, understanding the essential components of computer science and how software is developed allows you to design systems that work together better. There are many careers that go beyond computer science and intersect with other disciplines. Computer engineering is obviously essential because if we can't build computers, then we won't be able to run our software in the first place. So definitely very important. Data scientists use software to solve data problems and answer questions, and they rely heavily on either writing their own software or using more complex software that can benefit, where the scientists can benefit by knowing all of the details of how the software actually works. So again, being a data scientist relies heavily on understanding what can be done in computation and how the software achieves that. Computational science is a very large field that many people don't know about. From areas such as chemistry and biology and physics, just to name a few, scientists are actually using computer programs to simulate experiments that are either difficult or totally impossible to perform inside of a laboratory. So many areas of science are using computational modeling in order to answer questions that they can't otherwise do. And if you happen to really like all of computer science and you'd like to share it with the world, being a teacher or a professor is also a really exciting way to still enjoy it. So I've talked about what computer science is, the kinds of courses that we offer, and careers that intersect with computer science. And if you have any questions, you can reach us by finding our email addresses or phone numbers on the main hws.edu website. We also have a department website that we maintain ourselves. If you would like to check that out, math.hws.edu. Either way, track us down with an email and ask the faculty any questions that you want. We would love to hear from you. Thanks for your attention.